Hi everyone, thank you for joining. If you've worked with Android in embedded systems or automotive, you've probably run into the following challenges. Access to hardware is limited, systems are difficult to reproduce, and as soon as multiple teams need to work in parallel, things start to slow down. In automotive specifically, physical benches are expensive, hard to maintain, and often shared across teams, which makes iteration and validation more complex than it should be. My name is Bertrand Boisseau, and I'm the Anbox Cloud Product Manager here at Canonical. What I'd like to show you today is how we approach this differently by moving Android into the cloud and what that means in practice for real development workflows. All right, let's start with the Anbox portal. Anbox Cloud allows you to run and manage Android environments. You can use the Anbox UI or the CLI, the command line interface. In both cases, you get access to the same features. At a high level, Anbox Cloud allows you to run Android inside containers or virtual machines and access it remotely like any other cloud workload. These are our two main approaches, and it's important to understand when to use each. The first one is containerized Android. In this case, Android runs directly inside containers, which makes it very lightweight and fast to start. This is ideal for running applications, CI pipelines, and automated testing at scale. The second one is virtualized Android. Here, you're running a full Android system image with complete isolation and customization capabilities. This is typically used for system-level validation, infotainment development, or embedded use cases. Now, what's important here is that this is not emulation. With emulators, you typically run a simulated environment that is limited in performance and scalability, and it adds overhead. With Anbox Cloud, you are running the real deal. Real Android systems leveraging GPU acceleration and scaling them across your infrastructure. This makes a big difference when you need to run many instances in parallel or validate real-world performance. As you can see here, these environments can be created very easily, and they are fully reproducible and scalable. This means that teams can rely on consistent environments across development, testing, and review without spending time debugging environment-specific issues or having to manage hardware setups. So let me show you how you can configure your Android instance. From here, you can choose between different Android images. You can run Android Open Source Project, AOSP-based Android for general use cases, or Android Automotive OS, AAOS, which includes support for the VHAL, the Vehicle Hardware Abstraction Layer, enabling integration with vehicle systems. What's important is that both approaches can be used depending on your workflow, from early deployment and development to full system validation. And as mentioned earlier, you can launch instances either in containerized or virtualized mode, depending on the level of control and isolation that you need. I mentioned automotive quite a lot. Let's look at a typical in-vehicle infotainment setup. So your HMI team has built a great system UI for your infotainment system using Kanzi. And this is then sent to other teams for improvements and validation. What you see here is a real physical 8K cockpit bench used by Rightware. This is the kind of setup teams rely on for development and validation today, and it introduces complexity and challenges. These setups are powerful, but they come with constraints. They are expensive, limited in number, and typically located in one place, which means access is restricted, tests are queued, and teams need to coordinate around hardware availability. This constitutes a major bottleneck for developers. Now let's look at the same system running in the cloud. What you see here is the exact same Kanzi-based cockpit UI rendered at a full 8K resolution. It is running on Anbox Cloud and streamed remotely using WebRTC. From a user perspective, this behaves exactly like a local system. You can interact with it in real time, and the rendering quality and responsiveness match what you would expect from a physical setup. Now, this is important. This is not a simulation. It is the same Android system running the same UI stack, producing the same output. Here you can see both side by side. Rendering, transitions, behavior, everything is consistent. The difference is not in the system, but in how it is accessed. With Anbox Cloud, the system can be started on demand, accessed remotely and shared across teams. Teams no longer need direct access to the physical bench to work on the system. You can launch multiple instances in parallel and share them using simple links. This allows design, development, and validation teams to work in parallel without competing for hardware. Anbox Cloud is powering cloud gaming platforms worldwide, and we consider gaming to be one of the most difficult and challenging use cases when it comes to interacting with remote systems. You need to make sure that your user inputs, audio and video are always in sync with the lowest possible latency and the most constant ping or delay between your local device and your remote instance. With Anbox, you can benefit from that same level of graphical rendering performance and low latency than the one we provide for our gaming partners. What we've shown today is a complete workflow. Android systems can be created on demand, integrated into CI/CD pipelines, tested automatically, and made available for interactive reviews and demos. At the same time, they deliver the level of fidelity required for complex systems like infotainment, including 8K rendering. Another important point is that this does not require changes to how developers work today. There is no specific integration or plugin needed. Tests are executed using standard Android tooling, with the instance accessible over ADB, so developers can work exactly as they would with a physical device. Now, the goal is not to remove hardware benches completely. There will always be a need for hardware, but the goal is to remove it from the critical path of everyday development and validation. By doing that, teams can iterate faster, scale more easily, and collaborate without being constrained by hardware access. Anbox Cloud allows you to treat Android as a cloud workload. You can run, test, and share Android systems the same way you would any other software component. And if you'd like to explore this further, you can find more information in our documentation, you can watch the full demo video, or reach out to us directly to schedule a live demo. Thank you for watching, and see you next time.